and the focus is here. This is 0p as a focus. And okay, and then we have this should be a 9, 10. Okay. All right, and then number 4. Okay, here. Number 3 we have this, right? X equal to 4py. P is positive, so right now it's x squared equal to 4py. The p is negative. X, y. Or if p is negative, it's like this. It looks like this. And this point is 0p. That's focus. 0p is focus. Okay? So each one of these has its place. If it is y squared, so if y has a square, x doesn't have. It looks like that. And p is positive. And if p is negative, it's on the other side. If it is x squared equal to 4py, if p is positive, it's up, concave up. If p is negative, it's concave down. So those four curves, they are different. 1, 2, 3, and this guy. They are all different. Different curves. And their equations are different. Alright, now let's see if this is good enough for doing the problems here. Okay. Alright, so we just have to mention one more thing. Okay. We need to, okay, so for this one, I'm going to get a different color. Yeah. So for this case, there's a line here. This I'm going to use blue pen, okay? This line is x equal to, and if this p is positive, so this coordinate here is minus p 0. So this is x equal to negative p. X equal to negative p, okay, is the equation of directrix. Okay. And for this one, p here, okay, this will be if this p is negative, so if this is p, this will be negative p, right? It will be negative p. So this x equal to negative p. So x equal to negative p is the equation of the directrix. For this one, it's here. So this is also p. And this is, if this is p, 0p, right? So this point must be 0 negative p. So this line is y equal to negative p. So y equal to negative p is the directrix. And for this guy, the last one, p if this point is 0, if this point is 0, negative p, and this line is y equal to negative p. So this line, negative p, is called the equation of the derivatives. Okay. This is very simple. So once I no matter which one, okay. So say now so first of all, if it is y squared and x, then you know that the graph is sitting on the x-axis. It's very easy to memorize this. If I have squared y and only one power on x, no matter whether this is a positive number or a negative number, I know the graph is sitting like on the x-axis. Now depends on whether p is positive. If p is positive, it's like this. If p is negative, it's like this. And then from here, I know the focus, and I know the derivatives. And the equation is the same equation. X over negative p, x over negative p is the equation of the derivatives. And the equation of the point here is all the same. This is the same thing. This is the same as this. For the y, for the x value 4py, okay. This is the focus. This will y with the negative p will be the derivatives. And then if you look at the other case, no matter whether p is positive or negative, its focus is always the form is the same, 0p, 0p. Y with negative p, okay, y with negative p, so this is p. Alright, so I guess now we can do some exercise along those lines. It's actually just far from this piece of paper. So I'm going to work on, this is 10.4. Let me work on number 13. What's number 13? You can see number 13. Everyone can see it. Okay, number 13. Graphing parabola. Sketch a graph of the following parabola. Specify the location of the focus and the equation of the derivatives. Use a graphing calculator method for the meaning. Okay. Okay. So 13 is what? X equal to 12 y. So this I can write it as 4py with p as 3. So if I look at this, I know what graph looks like. It's x squared. X is squared. So that means the graph, it looks like either like this or like this. And it depends on what p. If p is positive, it's like this. If p is negative, it will be like this. So this is actually here for the picture. Okay. This is x, this is y. Okay, and then p is 3, right? Let's say this is 3. So 3, 0, 3 is a focus. It's a focus. And then this line, this particular line. If this is 0, 3, this will be 0, negative 3, right? So this line is y equal to negative 3, y equal to p. Okay? Y equal to negative p. This is the derivatives. Yeah, that's what they asked us. if it is so if it is x squared equal to 4p1 and p is 3, 4p1, p is positive, then the graph looks like this. 0p, 0,3 is the focus, and y equal to negative p is negative 3 is the directrix. Okay? Yeah. Yeah, that's all they want us to do. That's it. They just specify those two things. So all these things are like this. Let us maybe look at, let me pick another one, okay? I want to look at 15. Okay? It is x equal to minus y squared over 16. Alright? Okay. So first of all, I want to write it in, well, if I look at this, I know I want to write it as y squared equal to 4px. Because I have a square of y, and I don't have square of x, I only have square of y. Okay, so multiply this by 16, and then switch the signs. Multiply both sides by negative sign. Okay, I got this, so this is my equation. So first of all, I want to identify what p is. P is obviously 4 times p is negative 16, so what is p? P is negative 4. Okay. Now this y squared equal to 4, because p is negative, it is this graph. Wow. And negative 4 is here. It's negative 4. Negative 4 here. And this negative 4, 0 is the focus. And they ask for directrix, right? Directrix is this one. It'll be 4 here. That's a directrix. So x equal to 4 is the directrix. All right. And now let's do. Now I'm going to talk about. Yeah, we still have a third type of graph to talk about. It's called hyperbola. Okay. So next group of the one we're going to talk about is hyperbola. Now, hyperbola is very important in application. Of course, all of them are important, otherwise we wouldn't talk about it, right? But where do we use it? That's more important. Where do you use this hyperbola? The graph looks like a perfect graph. Yeah, the graph looks like this. Another one is hyperbola. And the hyperbola looks like that. Looks like an upside down cone, right? You know, the two cones in the size and how it is. But anyway, hyperbola looks like this. Looks like this. Or looks like either this one or this one. Or this one. Either this or this. Now where do we use this one? There's a very important application of this is the following. Say suppose there's a thunder